You know, when you look up at the night sky, it's easy to forget about the thousands of satellites orbiting over our heads. For decades, they were pretty much on their own up there, like lonely voyagers working in total isolation. But that is all changing, and fast. Today, we're going to talk about the incredible journey of how we're turning that empty space into a seamless, fully connected extension of our internet. It all boils down to this one simple but totally revolutionary question. What if satellites didn't have to work alone? What if they could actually team up, cooperate, and act as a single unit? It sounds simple, but that one idea is completely reshaping everything we do in space. And to really get why that question is such a game changer, you have to look at the old way of doing things. For years, a satellite was basically an island. It could only phone home to a ground station during the few precious minutes it was flying directly overhead. If you missed that window, tough luck. You could be waiting hours for your next shot, which meant huge delays for getting critical data back down to Earth. But the idea for something better, something cooperative, actually started taking shape a long time ago. So let's hop in the time machine and go all the way back to the year 2000. An ambitious project from the Air Force Research Laboratory was starting to imagine a completely new way to design a space mission. They came up with this term, a satellite cluster. And the key here, the thing that made it different, was that the mission could only be done by multiple spacecraft working together. This wasn't just about launching more satellites. It was about creating a single, powerful system out of a bunch of smaller, coordinated parts. So, the first big test for this concept was a mission called TechSat-21. And the goal was absolutely brilliant. Instead of building and launching one single, massive, incredibly expensive radar satellite, they asked, what if we could use a whole group of small, cheaper satellites flying in perfect formation to create a virtual large antenna in space? And this old diagram just perfectly captures the idea. The theory behind it is so elegant. By taking the signals from each of those small satellites in what they call the sparse aperture array, and then combining them just right, you could get the same power as one gigantic antenna. Plus, it would be way more flexible and a lot harder to break. Okay, so that was the dream, back in 2000. Now, let's fast forward to today. And wow, that foundational idea has absolutely exploded into a reality that is bigger and more complex than I think anyone could have possibly imagined back then. Just take a second to look at that number. As of right now, Starlink alone has more than 6,750 satellites up there. We've leaped from thinking about small clusters of, say, 4 or 8 satellites to these truly mind-boggling mega constellations. And what that creates is a dense, interconnected web of satellites in low Earth orbit, or LEO, that literally blankets the entire planet. That simple, sparse array from the old diagram has become a global mesh network. Now, here's why this is such a big deal. Your traditional TV and weather satellites are in what's called geostationary orbit, way up at almost 36,000 kilometers. That distance creates a long signal delay, or latency. We're talking over half a second. But these new LEO constellations, they're orbiting at just 550 kilometers. And the result? Latency just plummets to around 25 milliseconds. That's fast enough for real-time video calls, online gaming, you name it. But here's the twist. This incredible density creates a brand new kind of problem. As researchers have pointed out, these new constellations are just orders of magnitude bigger than even our GPS network. It's an amazing resource for sure, but it also creates a problem of, well, too much choice. I mean, put yourself on the ground for a second. At any given moment, you might have over 40 of these LEO satellites flying overhead. If you're trying to get a super precise location, how in the world do you pick the best combination of satellites to use? It's a really complex geometry puzzle, and it's something researchers are working on right now. So, we've built this amazing global network that's connecting the Earth. But what's next? Well, this is where it gets really futuristic. We're now looking at the next great paradigm shift, using these constellations to create an internet for space itself. This is a concept called Mega Constellation Services in Space, or MCSS. And the idea is just fantastic. Take the existing internet service from a company like Starlink and offer it as a service to other satellites flying around in even lower orbits. Basically, other spacecraft become customers of a space-based ISP. The beauty of it is just how simple it is. The network is already there, it's already serving us down here on Earth. MCS just adds a new kind of customer, other satellites. And just like that, you solve that original lone satellite problem. You give spacecraft continuous, real-time internet access anytime, anywhere. I know what you're thinking. This sounds like something straight out of a sci-fi movie, but it's real and it's happening right now. And it's all thanks to this perfect storm of incredible technologies that have all matured at just the right time. I mean, think about it. You've got satellites talking to each other with lasers, creating that mesh network in orbit. You have advanced antennas for pushing huge amounts of data. You have super efficient ion engines to let them dodge and weave. And maybe most importantly, you have cheap and frequent launches so the network can constantly be repaired and upgraded. So, you take the MCSS concept, you power it with all this amazing new tech, and what do you get? You get a vision of a future where our networks on the ground and our networks in space are one and the same. This seamless communication fabric, well, that's the foundation of what we're starting to call 6G. And here's where it gets really interesting for the future. In this 6G world, satellites are going to play two totally different roles. Some will act as user equipment, or UE. You can just think of them like a smartphone. They're a client using the network. But others will act as a GNB, which is basically a cell tower in the sky, providing service to things below. The critical piece here is that global standards bodies like the 3GPP group that defines our mobile networks are building these space assets directly into the standards for 6G. This is what enables true cooperative transmission, where satellites and cell towers on the ground all work together as one massive intelligent network. And if you want to see just what kind of impact this has, look at this chart. It is staggering. With the old ground station networks, you measured your data delay in minutes, sometimes even hours. With MEMCSS, we're talking about maybe 50 milliseconds. That's not an improvement. That is a complete revolution in how we operate in space. And the sheer amount of data we're talking about is just mind-blowing. A single Earth-observing satellite with the right equipment could potentially send down over 5 terabytes of data every single day. That's an incredible amount of science that can be analyzed in near real time instead of weeks later. So, the big takeaway here is this. We are watching space evolve from this distant frontier of isolated, specialized robots into a fully networked, real-time extension of the internet we use every single day. You know, the researchers who are actually developing this framework put it perfectly. They call it a genuine paradigm shift. Giving any spacecraft uninterrupted internet access just completely changes the game for what we can build and what we can discover in orbit. And that's really the big question I want to leave you with. We are moving from being a planet with an internet to becoming a truly connected planet, where Earth and the space around it are all part of one single network. So what new science, what new applications, what amazing discoveries will that kind of seamless connection finally unlock?